All right, strap in everyone because we're diving into the world of AI video generation today. And get this, we're talking about making these videos fast, like really fast. We've got a paper here tackling a big problem in the field. Speed. It's kind of like, imagine rendering a CGI movie, those big blockbuster films, but doing it like one frame at a time. It would take ages, right? Turns out AI video generation can be a bit like that, a real-time sync. But this paper, Denoising Reuse, exploiting interframe motion consistency for efficient video latent generation, it claims to have found a shortcut. And thankfully, expert speaker is here to help us decode it all. Expert speaker, ready to break down the speed demon.
Absolutely. This is a fascinating one, especially for the AIGC folks out there.
Perfect. So who are the masterminds behind this research?
So the lead authors on this paper are Chenyuang Xuyan and Yixuan Chen. And they're coming from some pretty impressive backgrounds, I gotta say. We're talking ByteDance, the University of California, Santa Barbara. They've got some serious AI chops.
All right, so we've got a powerhouse team tackling a big problem. Set the scene for us. What's the issue they're trying to solve?
Well, right now, creating high-quality AI videos, it's incredibly resource-intensive. It takes a ton of processing power, and I mean a ton. It's like, imagine trying to run a marathon, but you're carrying a refrigerator on your back. It's that level of effort.
Okay, so not exactly a walk in the park.
Not at all. Current methods, they often generate each frame individually, and that just takes forever.
So like writing a novel, one word at a time.
You got it. And for AIGC, this is a huge bottleneck. We can imagine all these amazing applications, right? But if it takes ages to make even a short video, it's just not practical.
That makes a lot of sense. So how does this paper with this catchy title, Denoising Reuse, how does it propose to speed things up?
Well, they've introduced something they call Dr. Mo, which stands for Diffusion Reuse MOtion. Catchy, right?
I like it.
And the core idea is honestly pretty intuitive. They're using the consistency of motion between frames to their advantage.
Hold on, are you saying this AI, it's learning how things move in the real world? Like it's figuring out physics to make videos faster?
In a way, yeah. Think about it. When you watch a video, objects don't just teleport around randomly, do they?
Right, there's a flow to it.
Exactly. There's a natural progression, a smoothness to their movements. Dr. Mo, it taps into that consistency to work smarter, not harder.
Okay, this is blowing my mind a little bit. So instead of creating each frame from nothing, it's using info from previous frames to predict the next ones.
Exactly. And that right there, that's a game changer for efficiency.
So it's like, what? Teaching AI the language of movement. And then it can use that language to write its own story, so to speak.
You got it.
But how does this learning process actually work? What makes Dr. Mo tick?
So it all boils down to two main parts: the Motion Transformation Network, or MTN, and the Denoising Step Selector, or DSS.
Okay, hold on. I'm already getting lost in the acronyms. Break those down for me. What do they even mean?
Don't worry, they're not as scary as they sound. Think of MTN, right? The Motion Transformation Network. Think of it like the choreographer.
The choreographer, okay.
It looks at these early stages of video generation when the frames are still super rough.
Yeah.
We're talking like blurry blobs here, not the final high-definition product.
Gotcha, the rough draft.
Exactly. But even in that early noise, the MTN, it can detect motion patterns, the twirls, the jumps, you name it. It's picking up on those movements.
So it's like creating a playbook for the video's action.
Exactly. It generates what researchers call motion matrices, which are basically like mathematical cheat sheets describing those movements.
Okay, so that makes sense. We've got our choreographer, the MTN, but you said there's another part, the DSS. What does that one do? Right, the DSS, the Denoising Step Selector.
Yeah, so if the MTN is like the choreographer, the DSS, it's like the director coming in and saying, okay, we got the basic moves, but let's add some flair.
I like that analogy. Makes sense.
Yeah, the DSS, it's all about finding that sweet spot, balancing efficiency and quality, because you don't want to lose that speed.
Right, because what's the point of making it faster if it looks terrible?
Exactly. So the DSS, it looks at what the MTN has put together, all that motion info, and it figures out the optimal point to switch gears. Like, okay, we've squeezed all we can out of motion prediction. Time to generate those finer details, make it really pop.
So it's like knowing when to let the dancers freestyle a bit, right? Add their own personal touch.
Exactly. You got it.
This is wild. So Dr. Mo, it learns how to move, figures out when to get artsy, But did it actually work? Did they put it to the test?
They did. Oh, they absolutely did. They used a couple of main data sets to see what Dr. Mo could do.
Okay, like what?
So first, they used something called UCF 101, which is full of everyday actions. Stuff like cooking, playing sports, the kind of videos you see all the time.
Okay, so pretty relatable stuff.
Exactly, real-world stuff. And then they also used MSR VTT, which is interesting. It focuses on videos that are described by text, like those short caption videos you see online with music and stuff.
Oh, yeah, I know those. Okay, so they covered a good range there. But what about the results? Did Dr. Mo pass the audition?
Dr. Mo didn't just pass, it stole the show.
No kidding.
Seriously, when it came to speed, it blew the competition out of the water. Up to 4 times faster than some of the other leading methods.
4 times! Get out!
Yeah, no, seriously, we're talking generating a 16-frame high-res video in a matter of seconds.
Hold on, seconds. That's basically instantaneous.
It's getting there. It's getting really close. But here's the real kicker. It didn't sacrifice quality for speed.
Okay, because that's always the worry, right? Make it faster, but it looks like a blurry mess.
Right, but this is different. They actually found Dr. Mo achieved comparable or even better results than the competition when it came to visual quality, how well it matched the input prompts, all of that.
Wow, so it's like having your cake and eating it too. Blazing fast, and it looks amazing.
Pretty much.
This is incredible. But they didn't just stop at making it faster, did they? They wanted to really understand what makes this thing tick.
Oh, yeah. They dug deeper. They did what's called an ablation study.
Ablation study sounds intense.
It's kind of like, imagine those cooking shows where they make the recipe a few times, but each time they leave out one ingredient.
Oh, to see which ingredient makes or breaks a dish.
Exactly. They did the same thing with Dr. Mo, tweaking different parts of the model to see how it impacted performance.
Clever. So what'd they find? Was there a secret ingredient to Dr. Mo's success?
You could say that. One of the biggest takeaways was that the timing of that switch, when Dr. Mo goes from predict the motion to let's get detailed, that timing is crucial.
Ah, so it's not just about knowing how to move, but when to focus on those details, those artistic flourishes.
Exactly. Switch too early, you get that blurry mess. Switch too late, and you might as well have generated each frame from scratch and lost all that speed.
It's a delicate dance, isn't it?
It really is.
This reminds me of, all those sci-fi movies where they show robots trying to move like humans, and they always get it a little bit off, like something looks just not quite right. It seems like this research, it's like cracking the code of natural movement.
Yeah, it's a big step in that direction.
But there's still a lot more to explore, right? Where do we go from here? What did the researchers say about the next big challenges for Dr. Mo?
See, that's what I love about this paper. They're not just content with what they've achieved. They're already looking ahead to the next big thing. And for them, it's all about tackling even more complex movements and, crucially, longer video sequences.
So they've conquered the waltz. Now it's time for something a bit more high energy.
Exactly. Think about the incredibly fast, intricate movements we see in nature. A hummingbird's wings, a school of fish, or even just the subtle expressions on someone's face during a conversation.
Right, those micro movements, they can be so quick, so detailed.
Exactly. Capturing that, recreating that, it's incredibly hard, even for us humans,
Makes sense. Those super fast, complex actions, that's a whole other level.
Yeah.
Did they mention any other areas for future research?
Yeah.
Yeah, it's like Dr. Mo's got the slow, graceful stuff down, but those quick, intricate moves, that's the next hurdle to clear.
For sure. And they were very open about the challenges of scaling this up, too. Right now, Dr. Mo can make a short video in seconds, which is amazing.
Yeah.
But a whole movie, a feature-length animation, that's a whole other story.
It's like the difference between, baking cookies and building a skyscraper.
Exactly. The ambition is there, but the tools need to catch up.
Totally. But even with those challenges, this research is huge, right?
Absolutely. Just imagine anyone could create high-quality videos no matter their technical skills.
Wow, it's like democratizing video creation, giving that power to everyone.
Right. And think about the possibilities for education, entertainment, you name it.
It's like we're on the verge of this creative explosion, all thanks to AI.
I know. And it gets even wilder when you think about, blurring the lines between different kinds of media. What if you could seamlessly blend AI-generated video with real footage? Or even VR.
Oh, that's next level. It's like stepping into a whole new world of storytelling.
Exactly. The possibilities are endless.
This paper, this Dr. Mo, it really feels like a glimpse into the future of video.
Absolutely. And the most exciting part, for me at least, is that this is just the start.
Right. It feels like we're just scratching the surface here.
Totally. The researchers themselves said that Dr. Mo is a huge step forward, but there's still so much more to learn and explore in this field. It's an amazing time to be working in AIGC, that's for sure.
I bet. Well, expert speaker, this has been a fascinating deep dive into AI video generation. Thank you so much for guiding us through it.
It's been my pleasure. Always love a good deep dive into cutting-edge research.
And there you have it, listeners. We explored the exciting world of AI-generated video, met the speed demon itself, Dr. Mo, and even got a glimpse into the future of video creation. Until next time, stay curious, and remember, the only limit to creativity is your imagination. This is The Deep Dive, signing off.